On the radius of convergence for that messy thing, how are we going to do it? We're going to do the ratio test. There's a ratio test say, says the limit n goes to infinity of the absolute value of a sub n plus 1 over a sub n. If that's less than 1, the series converges. Wherever that's less than 1, the series converges. So, okay. So the limit n goes to infinity. All right, so let's start. We're going to do the a sub n plus 1. So plug in n plus 1 right there, become n plus 1. Factorial, the bottom 1 times 3 times 5, da, da, da. I'm going to plug in right there n plus 1. So that'll be 2 times n plus 1 minus 1. And the x, I'll put it up here on the top, x to the n plus 1, that guy right there. Now, that's it. That's all that's a sub n plus 1 divided by a sub n. What's a sub n? Well, that's going to be the in fact, that's going to be the exact thing. N factorial over 1, 3, 5, da, 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 2n minus 1. And, but let's just flip it up because we don't divide, fraction over fraction. Just take the bottom fraction and flip it up because dividing is upside down multiplying. So we'll do that. So we're going to go, okay, times the upside down. So this will be the, let me make it bar here. This will be the 1, 3, 5, dot, 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 2n minus 1. And we'll have the in factorial on the bottom. This x then was over 1, so when it's flipped down to the bottom, it'll be down there. Absolute value, less than 1. It'll converge wherever it's less than 1. Okay, let's simplify this mess. So what I'm going to do, okay, actually, let me give it a tad bit more room there. There we go. Whoops, that's not what I meant to do. Okay, there we go. Okay, so I'm going to draw this fraction here. I'm going to make this, what is this? I'm going to distribute this right here. This is 2n plus 2 minus 1. This is 2n plus 1. So it's going all the way to 2n plus 1. So this is 1, 3, 5, da, da, da. And then that must mean what's right before 2n plus 1? 2n minus 1. How do I know that? Well, because it's going up by 2 every time. Up by 2, right? Up by 2. So if you go down by 2, if you subtract 2, 2n plus 1 minus 2 is 2n minus 1. So I just want to list them all why, because I want to cancel with that part on the top, you say. Okay, what about the top here? N plus 1 factorial. Do you realize that's n plus 1 times n factorial, right? That's like taking, 7 factorial and saying, look, that's 7 times 6 factorial. You can just go down by 1 and hit the factorial. So go down by 1. Why am I doing that? I want this to cancel with that on the bottom. See the game plan? Got some cancellations in mind. So let's clean it up. What do we got in the top? 1, 3, 5, dot, dot, dot. 2n minus 1 over n factorial. And you know what the x's are going to do, what they do every time. This is x to the n plus 1 is x to the n, x to the 1. This x to the n down the bottom. Cancel, cancel. Absolute value less than 1. Now we cancel all steps. So 1, 3, 5 all the way to 2n minus 1. 1, 3, 5 all the way to 2n minus 1. So that's good. N factorial, n factorial. That, yeah, so that's a lot of good, happy cancellations. So let's take it from there. So now we have the limit n goes to infinity. What is left? We have n plus 1 on the top. So I like to circle or cross out everything so I don't miss any terms. N plus 1, x. What's on the bottom? 2n plus 1. And that's it. Absolute value. I guess we don't need that bar going quite so far, huh? Less than 1. Okay, so now when I go to infinity, what's gonna happen with this part? When you go to infinity, all that matters, remember, is the most powerful term on the top, most powerful term on the bottom, right? So that's effectively n over 2n. I said 2n, but I didn't write it. 2n times x, absolute value less than 1. That's what's going to really happen. When you go to infinity, all that matters most power, infinity plus 1, the 1 doesn't do anything, or 2 times infinity doesn't matter. And then these ends cancel, And so we get absolute value of x over 2 less than 1, right? The 2 is still on the bottom. So last step to get x alone, multiply by 2 on both sides cancels out. Absolute value of x less than 2. There's the radius of convergence. It's 2. As long as the absolute value of x is less than 2, that's the answer they got. As long as the absolute value of x is less than 2, this series will converge. And so there we go. It's called the radius of convergence.